So I'm going to begin the recording. 1.3, talking about lines. I don't think there's much here on this first page. Yeah, no big deal. All right, next we're going to talk about the slope of a line, or the first thing we're going to do is talk about the slope of a line. All right, so it reads, we first need a way to measure the steepness of a line, or how quickly it rises or falls as we move from left to right. We define run to be the distance that we move to the right, and rise corresponding to the distance that we rise. The corresponding distance that the line rises. The slope of a line is a ratio of rise over run. So we've heard rise over run before. Here in the figure we see different slopes. We have a ramp, we have a roof, and then the slope of a road. All right. Similarly, we have here in this figure we have a mountain climber, which by the way, I think, if I'm not mistaken, here in a moment, and I'll just go ahead and scroll down. We use the letter M for slope. Obviously, it would just be way too convenient if we can just use the S or something, right? All right. Well, I believe we use the letter M because M, I think, is French or something, and it means to monitor, or it's M stands for monitor, which I think stands for climb. I might be wrong about that, but whatever. No big deal. Been wrong before. Anyways, so here we got the slope of the line. I'll go over this real quick. All right. Again, none of this should be new to you. So hopefully, if I do go through this a little too fast, you will email me and be like, hey, I didn't really catch that. So, and many of you are not shy about emailing at all. So I have no doubt that you will definitely email me if you have questions. Slope of a line. The slope M of a non-vertical line that passes through the points A, which consists of x sub 1 and y sub 1, and B, which consists of x sub 2, y sub 2, is M is equal to rise over run. All right, or in other words, notice here we have a y2 minus y1. All right, it doesn't matter what you necessarily denote as y2, what you denote as y1, as long as you remain consistent and do that for x2 and x1 as well. Okay, all it is just the difference of the y's and the difference of the x's. That's it. So let's see if we can go ahead and put an example up here. Actually, no, this is interesting. Okay, so right here it reads, the slope is independent of which 2 points are chosen on the line. We can see this is true from similar triangles in figure 3. So you can take the time to look at this if you really care. And if you really care, honestly, talk to me, because I find mathematics interesting. I've been doing this for 4 years, and I've noticed that not many students find math interesting. Isn't that a shocker? But anyways, notice how these triangles here and here, all right, they have the same slope. Doesn't matter what 2 points you use. In this particular case, this A, okay, maybe it can. This A and this B, maybe we should circle it, has the same slope of this A and this B. Okay, and that's all that we're trying to say there. All right, this is interesting stuff, or important stuff rather. It would be the slope of a line and what we call what. So can we do current page? Yeah, we can. Okay. So slope of a line. I read earlier that we read these slopes from left to right, and if we go from left to right here, we see that we have a positive slope. Let's do a different color. Let's do blue. Reading from left to right, if we go up, we have a positive slope. Reading from left to right, if we go down, we have a negative slope. If we have a horizontal line, that is a zero slope. And then lastly, if we have a vertical line, we have a no slope. Okay, so why would we have a no slope there? We'll see here in a moment, I believe. Let's do next. Go to the example. So for this, I am just going to snip this because I do believe you guys can subtract. You're in college pre-calculus course, so I'm just going to snip this entire thing, and with the figure as well. Okay, we'll go over it real quick though. All right, so example 1, find the slope of a line that passes through the points P, which are 2, 1, and Q, which are 8, 5. Okay, again, it doesn't matter what you denote as point 1 and point 2, but for this particular example, it looks like this is essentially point 2, and this is point 1. And all they did, or all we're going to do as well, notice in the solution is m is equal to the difference of y's over the difference of x's, and it chooses, again, the second point to be, the y2 and x2. And so you can see we have a 5 minus 1, so this is the 5 minus 1, which is 4, and then we have the 8 minus 2, which is 6, and 4/3 is, or I'm sorry, 4/6 is 2/3. All right, and that's all it is. Finding the slope between 2 points, and these 2 points are here. Okay, now real quickly, we have said that this is this number 2/3 would be denoted as a slope, but we could also read it as rise over run. So if we were to look at this graph and starting at the point P, we are essentially rising 2 and running to the right 3. So we're going to go 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. Notice how the slope is the same in both cases. Now, before I do get a little too far, I do want to talk about something. I remember when I was taking this course a long time ago, we might have a problem with a point here. Oh yeah, we need to do this. With some point here. Oh, yeah, I can only put a dot. I can't actually go in circles, make a small circle. And then I would be like, the problem would read, all right, so plot a point with a slope 4. And I'm thinking, okay, slope 4, so rise. I'm going up 4 and over 1, but I'm not on the graph at all. Okay, so what you can do there is if it kind of think backwards. So instead of rising 4 and running to the right 1, obviously, again, that would be off the graph. You can just do the opposite, and you can do one of the opposite. You can fall 4 and then go to the left 1, and that would still create a slope of 4. So hopefully that's not too confusing, but I'll stop there just in case. Might just be something that you have to figure out on your own, but now you have it. All right, so point slope. Okay, so point slope form. This is pretty important. Let's go and put this, we'll put the figure in there since this is reading to C point or figure 5. Okay, so we're going to come across, I think maybe three equation types today. The first one being the point slope form, and point slope form is what I like to call the equation generator. Okay, from the point slope form, we're going to get, and you've heard this before, but if you forgot, that's fine. You'll get the slope intercept and then standard form. Okay, the point slope form is the granddaddy of them all. It is the equation generator, and I'll show you what I mean by that later on. But anyway, let's read this. Now let's find the equation of a line that passes through a given point P and has slope m. A point P, xy, with x not equal to x1, so saying that our x's are not the same, lies on this line if and only if the slope of the line through P1 and P equals to m. And we see that. All right, now imagine what we did was we got rid of the denominator, so we would multiply both sides here by x times x minus 1. So if we did that, multiply this side by x minus x sub 1, and multiply this side by x minus x sub 1, we would get this equation here, right? The x minus x sub 1s would cancel on the left side, and then we would just be multiplying m times x minus x sub 1. So all we're doing to get the point slope form is getting rid of the denominator in my slope equation, right? And this is our point slope form. I'm going to put that right there. Point slope form. y minus y1 is equal to m times the quantity of x minus x1. This does need to be memorized. Okay, again, I'm going to just simply snip this. It's not going to be a thing that I do all the time, but again, we are going really fast through these first few, and I don't want to go over like I did last time. Even though many of you did stick around, so bravo. And then we'll put the figure on there as well. Okay, so example 2 reads, find the equation of a line through this point with slope this. Now, we're going to be going over a few equations here in a moment. And again, the first one we're going over is the point slope form. Now, how do I know when to use the point slope form as opposed to slope intercept and standard form, which we'll cover in a little bit? Well, it's really easy. You use the point slope form when you have a point and a slope. Mind-blowing stuff, I'm telling you. So if we have the point 1, negative 3 and the slope negative 1/2, I'm going to go and actually go ahead and do this. So let's go ahead and write the equation. Okay. So what we're going to do is we're just going to fill in the blanks. Okay. So we said the slope was negative 1/2. So what I'm going to do is I'm going to erase this slope and I'm going to put a negative 1/2. Looking at this point here, my x value is 1 and my y value is negative 3. So what I'm going to do is I'm going to replace the x sub 1 with a 1. And I'm going to replace this y sub 1 with a negative 3. So negative 3. Now if I proceed through this, we'll have y plus 3 is equal to negative 1/2 x minus 1. And that is, we use the point slope form, and notice how, okay, it says rearrange here, and we'll go ahead and do that as well. But no, I'm not going to get ahead of ourselves. All right, we have our point slope form. We put in our point and our slope, and then we rearranged to get to this point right here. And then B says, it reads to sketch the line. We have a slope of negative 1/2. So what we're going to do, looking over here now, we're going to look at our point. Our point we said was 1, negative 3. Now it has a slope of negative 1/2. And as we saw on the, right here, negative slopes, they go down, right? So instead of rising over running, we're going to get essentially, kind of fall and run. Okay, if we have a negative slope, we kind of fall and run. So notice how instead of going up 1 and over 2, we're going to go down 1 and over 2. So we go down 1 and over 2. Okay, so this is one I can just straight up do. We want to find an equation of a line through this point. Okay, so we're trying to find, that's through the points rather. We need to find an equation that goes through both those points. So how do we do this? Well, first of all, we need to figure out what the slope is. So how do we figure out the slope is? Well, we have to use our slope formula. So it's going to be m is equal to, it's going to be the change in y or the change in x's. So we're going to do negative 4 minus 2 over 3 minus a negative 1. Okay, I did negative 4 minus 2 and then a 3 minus a negative 1. That's all I did, just change in y over change in x. Well, negative 4 minus 2 is negative 6. And then we've got 3 minus a negative 1, so that's the same thing as saying 3 plus 1, right? So it's 4. Right? And that's the same thing as saying negative 6 fourths, which is the same thing as saying negative 3 halves. So we have a negative slope, we're going down 3 and to the right 2. All right, but that's not, I mean, we care about that information, but that's not what we're trying to get to the end here. We're trying to find the equation of a line through those points, okay? Well, in order to find that equation, I told you that the point slope is my equation builder. So that was y, and we're gonna do both. This is why my lectures go over. And we'll do it another one, blue. Okay, so we're going to use 2 different points here, just to show you that it doesn't matter which point you use. Okay, so in the green, we're going to use this point, -1 and +2, and the blue, we're going to use this point, 3, -4. Okay, so we're going to say y minus, well, what's the y value of my green? Well, it's just 2, is equal to my slope, which is -3/2, times x minus, and then it's minus a -1, so let's say x plus 1. Okay, let's do the same for the blue over here. So we're going to say y minus, and y sub 1 is -4, so it's the same thing as saying y plus 4 is equal to -3/2, and then x minus 3. Okay, well, it certainly don't look the same, does it? Okay, well, what we're going to have to do here is do some rearranging, and I might have ran out of room. I don't know. Okay, so anyways, so we've got y minus 2 is equal to -3/2 x minus 3/2. Yeah, I'm going to run out of room. Y plus 4 is equal to -3/2 x. And then what's -3/2 and times -3? Okay, well, you might have forgotten, so we're going to do this real quick. Up here, -3/2 times 3. Okay, recall that times 3 could be the same thing as saying 3/1. And so we get -9/2. I'm sorry, it'd be positive because that's a negative right there. So plus 9/2. Okay, so this is not how I envision this happening. So we're going to snip this and put it on the next page. Okay, so we're going to put everything on the left side. So we're going to have a, let's actually go ahead and get rid of my 2 as a denominator. Okay, so I'm going to multiply the entire problem by 2. Put it in yellow, I guess. So we've got 2y minus 4 is equal to -3x minus 3. Same thing over here. We're going to have 2y plus 8 is equal to -3x plus 9. We're going to move everything to the left side, so we're going to have a 3x plus 2y, and then a -4 and a -4 plus 3. We had 3 to both sides. We're going to have a -1 equals 0. We add 3x, we got 3x plus 2y. We're going to subtract 9 from both sides, so we've got -1, and it's equal to 0. Okay, so recap, what I did here was, first thing I did was I got the slope. My slope was -3/2. So I needed to find an equation of a line through those 2 points given in the problem. Okay, in the green, I used the point -1, +2. In the blue, I used the point 3, -4. The reason why I did both of them is to show you that it doesn't matter which point you use, right? You're going to get the same equation in both. So it doesn't matter which one you use. One might be easier than the other sometimes. You know, like if the one in the green were both positive, I'd probably go ahead and use that, right? I don't want to deal with negative signs if I don't have to. But they both had a negative and they both had a positive, so it's not a big deal. But in the green, in the blue, I did it both ways. I won't be doing that in the future, but I just want to show you it does not matter which point that you use in the point slope, you'll get the same equation. And of course the note down there, we can use either point. We'll end up with the same final answer. Okay, so we talked about point slope, okay, on the previous slide, or in the previous section there. Now we're talking about slope intercept. Yeah, we'll go and read this. All right, so suppose a non-vertical line has slope m and y-intercept b. All right, we see that in the figure. We have my slope, which is m. We don't know what the slope is, and we have the y-intercept at b. Notice we're up here at 0, b. That's my y-intercept. So the point slope from the equation of the line with x equals 0 and y equals b, if we just plugged in b for the y-intercept and 0 for the x-intercept, we end up getting this equation that we are very familiar with, y equals mx plus b, which we call the slope-intercept form. And this is another equation that's going to have to be memorized. Let me see, maybe I can kind of hand wave through this one. All right, so we're going to snip our slope-intercept. No, put it over here. And then we're going to snip our example as well. All right, I feel like these examples are pretty easy to understand. There's not much that I can do to break it down even simpler, I think. Okay, but we'll go over it. So example 4, lines and slope-intercept form. A, find an equation of a line with slope 3 and y-intercept 2, or negative 2. All right, well that's not too hard, right? I mean, if we have a slope of 3 and a y-intercept of negative 2, if we just follow this equation over here, y equals mx plus b, the m is the slope, it goes in front of the x variable, and the b is the y-intercept. So if we have a slope of 3, the 3 goes in front of the x, and then the y-intercept of negative 2, and that's that. Pretty easy to understand, I believe. Next up, find the slope and y-intercept of the line at 3y minus 2x is equal to 1. All right, so all we do here is we're just going to solve for y. We'll do this green. So we have our equation here, and all we do is just solve for y. We add 2x to both sides and divide by 3, and therefore we get this equation, which is in my slope-intercept form, and it's very easy to tell that I have a slope of 2/3 and a y-intercept of 1/3. Maybe this will be worth snipping. Okay, so vertical and horizontal lines. If a line is horizontal, its slope is 0. Okay, and let's just examine why that would be it. No, I'm pretty sure they'll explain it. Okay, so if a line is horizontal, its slope is m equals 0. So its equation is y is equal to b, where b is the y-intercept, and we see that in this figure here. We see that we have the where our laser at. We have the horizontal line. It's because I have the equation at y equals b, b being my y-intercept. A vertical line does not have a slope, but we can write its equation x equals to a, so x equals whatever constant it is. So if we're over here at, let's say 3, then x is equal to 3. Becomes a horizontal, and I guess I can say something like that for b as well. If y is equal to 2, then we have a horizontal line at 2, at the y-axis where 2 is. The same can be said for the x-axis there if I just put a 3. Just vertical and horizontal lines. All right, I thought we would clear up more why a vertical line has no slope, but I guess we might be past that, so I'm going to talk about it real quick. Do a new page. Okay, so let's imagine we have us a graph. or a Cartesian plane, and I have a point here and here. Okay, and I'm asked to find what's the slope of that line. Okay, well obviously, you know, I made that made those 2 points be on top of each other because I want to have a vertical line, because I want to show that they do not, that there is no slope. All right, it's an undefined slope. So let's denote this. Let's denote this point to be some x. We're going to call it a, and we're just going to call this y sub 2. Okay, because it's a little bit lower, so we're going to call this point b, and we're going to call this point y sub 1. Okay, so right here we have y sub 1, right here we have y sub 2, and honestly I probably shouldn't put a there, so let's do this. I mean, probably shouldn't put b there, so we'll put a here. Okay, all right, so if I want to find the slope of that, I would do the change in y or the change in x. Okay, so it doesn't really matter what y is, and I mean, honestly, I guess for the sake of not being very rigorous here, we'll just call these y values, we'll call them, we'll call this one 3, and the next one 1. Okay, so 1, 3, and of course 2 would be right there. Better. Okay, so if we did the change in y or the change in x, we would say m is equal to 3 minus 1, not a big deal, right? But then we'd have a minus a, so we'd have 2 over 0, which is undefined. Okay, and again, if I could change that a to to be a 3 or something, right? And it'd be 3 minus 3 is 0. But anyways, that's why we say that a vertical line has no slope, or an undefined slope. Let's see, did I snip that part? Yes, okay. All right, so we can go to the next page. So example 5, all of these can be seen in the graph, and I'm just going to snip this. New page. So an equation for the vertical line through 3, 5 is x equal to 3. So is that even showing it? It's actually not. That's interesting. Okay, so at point 3, 5, 2, 3, 2, 3, 4, maybe like right here. Oh, hang on. Might be about right here. You can't see it. Forget it. I'll just read it. An equation for the vertical line through 3, 5 is x equals 3. So if we have a vertical line, that equation is just x equals to something. Okay, where are we crossing the x-axis? Same can be said for a horizontal line, where are we crossing the y-axis? And we see the blue line, y is equal to -2. That's a horizontal line. It's just simply x equals to something as a vertical line, y equals something as a horizontal line. B, the graph of the equation x equals 3, which we just said. C, an equation for the horizontal line through 8, -2. Like, it didn't even have the point 8, -2 on here. But anyways, an equation for the horizontal line through that point, okay, we say horizontal line, we're just talking about y equals to something. And depending on where that horizontal line is, in this particular case, y is equal to -2. D, the graph of the equation y is equal to -2 is a horizontal line with y-intercept -2. So I guess there's not much to explain on this one, and that's why I'm pretty sure that's it. That's the solution. They just show a graph. It's a really terrible example. Okay, so the general equation of a line, all that is a proof to get to this. Now, generally, I do enjoy proofs, and I will show them from time to time. In fact, I'll show you a proof for the quadratic equation, quadratic formula rather, during this lecture, because I think it's pretty interesting. But for this one, we're not going to. Okay, so far we've had the point slope formula, we've had the slope intercept formula, and now we're going to have the general equation of a line formula. which is just simply ax plus by plus c. Okay, so example 6. This is a good one to do here. So we want to sketch the graph of the equation. So in order to sketch the graph, we need to know a couple of things. Okay, the first couple things that we could start off with is this. We could do one, get the x-intercept. 2, get the y-intercept. And 3, connect the dots. Okay, that's one way to do it. Another way to do it would be to put this into slope-intercept. And graph this way. We'll do both. Okay, so if we did the first method that I did, which was find the x and y intercepts, right? Yeah, it was in red. Okay, so in order to find the x-intercept, we have to set y equal to 0, right? So we're going to set y equal to 0. So we've got 2x minus 3 times, not 30, 3 times 0 minus 12 is equal to 0. Or 2x is equal to 12, or x is equal to 6. Okay. All I did was I zeroed out the 3, I added 12 to both sides, and then I got x equals 6. So next we're going to find the y-intercept. Set x equal to 0, and I'm going to go down just a little bit here. All right, so in order to find, in order to set x equals 0, we've got 2 times 0 minus 3 times y minus 12 is equal to 0. So that becomes a negative 3 is equal to positive 12, so y is equal to negative 4. Okay, and then once we get to this point, we're just going to connect the dots, and the graph, let's see. Looks like this. Current page, where can we put this? We'll put it right here. Okay, so notice what we have. My x-intercept is at x equals to 6, and my y-intercept is at y is equal to negative 4, and all we do is just simply connect the dots once I get to that. So what I would do is I would just say, okay, so here's my x-intercept, so it's a little off-centered. X-intercept, y-intercept, connect the dots. That's it. Okay, so that's one way to go about doing it. The next way would be to get this equation up again. The next way would be to put this into slope-intercept form. Okay, so if you recall, slope-intercept form was y is equal to mx plus b. So what we're going to have to do is we're going to have to solve this equation for y. So we're going to move everything to the right side. So we've got a negative 3y is equal to, we move everything to the right, so we're going to have a negative 2x plus 12. Okay, we're going to divide both sides by negative 3, so we're going to have a y is equal to, all right, so a negative 2 divided by negative 3 is a positive 2/3 x, and then a positive 12 divided by negative 3 is a negative 4. And we see here, whenever we graph using the slope-intercept form, my y-intercept being -4, I go down 4 units. Maybe I should do it in red, let's do it in blue. -4. I go down 4 units on the y-axis, and then I use that slope of positive 2/3. So what I do is I rise 2, 1, 2, and I run 3. And then I connect those dots. Okay, so those are 2 ways to go about graphing linear equations. You can either graph it by using the intercepts or the slope-intercept form. Sorry. And because I feel like I got a little tongue-tied, we'll do this. In the red, I said we graph using my intercepts, my x and y intercepts, and then connecting dots. In the blue, I use my slope-intercept and then I graph. And here in the red, notice how I got my x-intercept, my x-intercept, my y-intercept, and then I connected the dots. And here, I guess I pretty should have done blue, but whatever. I just rearranged my equation and put it into slope-intercept and graphed it. All right, so next up, we're going to talk about parallel and perpendicular lines. Okay, so we have the proof of parallel lines. You can look at that. And just for the sake of it, we're going to put perpendicular lines up here with it. Current page. Okay. All right, so parallel lines. 2 non-vertical lines are parallel if and only if they have the same slope. And again, I can't remember if it was this class, but if and only if basically means you could read things from left to right and from right to left. That's what the phrase if and only if means in logic and mathematics. All right, so perpendicular lines. 2 lines with slope m1 and m2 are perpendicular if and only if when you multiply the slopes together is -1. Now, of course, that's not what we're used to hearing. We're used to hearing negative reciprocals, right? Which is the same thing, as saying if we multiply the 2 slopes together, we would indeed get -1. But we have heard negative reciprocals probably since, what, 5th grade? Or in other words, m2 is equal to the -1 over m1. Okay, just negative reciprocals. So let's see, let's actually talk about what a reciprocal is real quick. A reciprocal would just basically be flipping a fraction. So we have a fraction 3/4. If we flipped it, it'd be 4/3. If we have a fraction 3, we flipped it, it'd be 1/3. Okay, and then the negative obviously would just be to just change the sign. That's it. Just change the sign. So if it's positive, change it to negative. If it's negative, change it to positive. And the reciprocal would just be to flip the fraction. That's it. One of these examples, I think example 8 is one I'm not going to do, and that's the one here. So yeah, we're not even going to deal with that. More proofs, example 8, I don't really like it. All right, this is good. We're going to, what time is it? We get out at 11. We're going to snip this whole thing again. Okay, so again, it's kind of hand wavy. I'm sorry, but I gotta be kind of quick here. So example 9, find an equation of a line perpendicular to a given line. So we are given the equation 4x plus 6y plus 5, and we have to find an equation of a line perpendicular to that line. Okay, so the first thing I'm going to have to do is figure out what the slope of that particular line is. No, I can't do that. I'm sorry. I feel like I'm cheating you a little bit if I try to hand wave this one. If we go over today, whatever. Okay, so let's do this. So find an equation of a line that's perpendicular to that line. Okay, so first thing I need to do is figure out what the slope of that line is. Okay, so in order to do that, I can do a couple of things, but in my opinion, the easiest would be just to put it into slope intercept. So I'm going to solve this for y. So it's going to be 6y. Yeah, I'm going to stick with that. Is equal to a negative 4x. I don't know what, minus 5. Right, and then I divide both sides by 6. So we've got y is equal to a negative 2/3 minus 5/6. All right, so I got my, oops, forgot the x there. Minus 5/6. All right, so I rearranged this equation, and from this I can tell that my slope is going to be negative 2/3. Okay. Now it says find an equation of a line that's perpendicular. So how do I find a line that's perpendicular to that line, the line given by 4x plus 6y plus 5? All right, well, if the slope of this equation is negative 2/3, all I have to do is just make an equation up that has slope of the negative reciprocal. So the negative reciprocal of negative 2/3, all right, so I change the sign from negative to a positive, and then I flip the fraction. So it would just be 3/2. Okay, well, I mean, I don't have to get fancy at all, so I mean, I can just say y is equal to 3/2 x, and that's it. I found an equation of a line that is perpendicular to 4x plus 6y plus 5 plus 5. It's equal to 0. Recap, I found the slope of that equation, and then I just made an equation up with the negative reciprocal. And of course, I mean, if you want to, you could say, plus 9. It doesn't really matter. But the point here is that we have a negative reciprocal. Okay. Example 10. Okay, example 10 is definitely something I don't have to necessarily do because this uses calculators, and I've told you before that on the test I do not have questions that involve calculators. So graphing a family of lines, use a graphing calculator to graph the family of lines. Y is equal to 0.5 x plus b. So what we're going to do here is, I don't know, is this going to be on the homework? What's my slope? Well, it's 1/2. Okay, so if I wanted to graph a family of lines for this particular problem, then I would just, all I'm doing is changing my y-intercept. All right, and notice how for this particular problem it's saying for b is equal to these numbers, and again b is just the y-intercept, and so we're just going up and down the y-axis. We're just going up and down the y-axis here with a slope of 1.5. Or 1/2, not really 1.5, but 1/2. And again, that's just calculator stuff that we do not do in here. Okay, so that's 1.3. Let's jump to 1.4. Solving quadratic equations. Here's something that we've done a lot of. Okay, so this is good. Okay, so this reads, a quadratic equation is an equation of the form ax squared plus bx plus c is equal to 0, where a, b, and c are real numbers and a is not equal to 0. Okay, now the reason why a cannot be equal to 0 is because if we had 0 x squared plus bx plus c is equal to 0, which we would have bx plus c is equal to 0, and that would just be a linear equation. Okay, quadratic equations we are familiar with, they make parabolas, right? Linear equations, line, they just make a line. So the reason why this definition goes on to state that a cannot be equal to 0 is because it would change the definition of what a quadratic equation is if we let a be equal to 0. Okay, and again, we've seen quadratic equations for many grades now. Now, the whole point, the whole reason why we use quadratic equations all the time in all of your college mathematics is because they're really easy to solve. I mean, well, not necessarily easy to solve, but in terms of our polynomials of degree n, the second degree polynomial, the quadratic equation, is usually the easiest to solve and easiest to factor, because once we start getting into third degree polynomials, fourth degree polynomials, it becomes abundantly difficult. So even if you are going into mathematics as a degree, you're gonna be dealing with quadratics for the rest of your life, because they're simple problems to just set up and go. Okay, but anyways, the reason why they're so simple is because of this: solving quadratic equations by factoring. Right, so some quadratic equations can be solved by factoring and using the following basic property of real numbers, which is a zero product principle, or zero product property, and this book calls it. AB is equal to 0 if and only if A is equal to 0 or B is equal to 0. That's it. So what does that mean? That means what we're going to do is we're going to set up some equation. Doesn't matter what. We're going to make it equal to 0. Their factors. We're going to make their factors equal to 0. Okay? So what does that mean? Something like x plus 3, oops, wrong one, and x minus 2 is equal to 0. Okay? These are factors. These are in the form a times b is equal to 0. Right? Now, saying x plus 3 is equal to 0, okay, that is actually pretty easy to solve, but it's not in a factored form, right? Because, factor, we're talking about multiplications, but at this point we can just solve x is equal to negative 3, and that's the end goal, is to get factored forms, all right, a multiplication, essentially, on one side, on the left, in many cases, and a 0 on the right. Now, of course, this also extends to not just a times b, but we could also say, we could say a times b times c times d times e is equal to 0, and then set them all equal to 0. And I don't know if we're going to see that necessarily in today's lecture, but to just give you a quick example, that'd be the same thing as saying, x plus 3, dang, I came along the wrong way, x minus 2, and x plus 1 is equal to 0. And, we know that x is equal to, say, negative 1, negative 3, negative 1, negative 3, negative 1, positive 2. Okay, so this zero product principle obviously extends out to however many terms that you have in factored form. Simply because I feel like you know how to factor, we're going to just paste this. Okay, so we're going to have to, okay, there we go. All right, so real quick, just because I had an issue the other day, if by some chance my open board is what I use to write on here, if by some chance open board freezes, okay, and it's not responding, I had this happen the other day. I'm recording this, and luckily, even if it's not responding, it records up to that point. Okay, so if this were to happen, if my open board is not responding, I'll just end essentially the lecture. Okay, not that you may be here, you may not be, I don't know, but I would end the lecture on Zoom, but I would reboot my computer, and then I will finish up the lecture, record it, and still post it to YouTube. Okay, so if by some chance this happens, it freezes my computer, you don't hear me anymore, I mean, you can just go, no big deal. But I'm not going to cheat you out of an education. I will continue with the lecture. And again, this did happen to one of my classes last week, and everything worked out smoothly. It was the lecture was in 2 parts, but no big deal. Anyways, example 1. Find all real solutions of the equation x squared plus 5x equal to 24. We know that we put everything on one side and make the right side equal to 0. We factor the left side, so x squared plus 5x minus 24. We factor it, turns into x minus 3x plus 8. If you forgot how to factor, go back to your review sections, check that out. And then once we got the x minus 3, x plus 8, here we set these terms equal to 0. X minus 3 is equal to 0, x plus 8 is equal to 0, and then we just solve for x, and this is, again, pretty easy. We just get x equals 3 and x equals negative 8, and therefore those are the solutions. All right, check your answers. So if you're anything like me, and I know you are, you don't check your answers. Many of you don't anyways, okay? And that's fine. There will be times where you have got to check your solutions, but I will tell you when those times come up. But for the most part, and again, I was like this as a student, I'm like this as an instructor. I don't check my work, sorry. But you can. All right, oh man, dang it, I knew there was something big. Okay, so we're gonna talk about completing the square. Okay, so I'll snip this, but I'm gonna go about doing things a little bit differently because I have my own personal way to go about doing our solving by completing the square. So I'm not even going to read that, but I will put that on the notes. All right. No, actually, no, I will read it because the whole point of completing the square. So reading this, to make x squared plus bx a perfect square, add b halves quantity squared, the square half of coefficient x. This gives a perfect square. So what this is saying is if we add b halves quantity squared to x squared plus bx, all right, we are completing the square, meaning we are adding or subtracting, I guess. Well, no, I guess it'd be adding since it's a squared. Adding the perfect number to make it a perfect square binomial. Okay, the example will clear it up better here in a moment. So completing the square. We're going to do A first, obviously. Okay, so the first thing you do before you even begin to complete the square, all right, you have got to make sure that your A value is a 1. Okay, so what that means is I need to make sure that this value right there is a 1. Okay, now obviously B, it's not a 1, it's a 3, but we'll deal with that in a moment. A is nice and convenient, so I'm going to go ahead and rewrite A as x squared minus 8x, and I'm going to go ahead and subtract 13 from both sides. Okay, now actually, no, let's actually bring that back for a second. Here's why. All right, so notice how if I were to try and solve this, all right, if I were to try and factor this equation, I wouldn't be able to, right? Because I would say, okay, so what are my factors of 13 that when I add or subtract them together will give me a negative 8? Okay, well 13 is prime, so it's only 13 and 1, and no matter how you cut it, 13 and 1 will never get negative 8. Okay, so that's why we're gonna have to complete the square. So what we're gonna do, so go back, we're gonna subtract 13. All right, this is very important. Follow along. I promise you, this will not be difficult. First thing I do, I call it my 0th step. 0th. And basically what that is just what we saw on the previous slide. Here, b halves quantity squared. Okay, so that's my 0th step. And then what I do here is I just put first step, I, do this, and I'll explain here in a second what I'm doing. Okay. So basically what I'm doing is I'm just going to fill in the blank. Okay. So my first step My zeroth step is just my formula. My first step, I'm going to plug in my b value. Okay, what is my b value? Well, look here, it's -8, right? And again, let's go back to quadratic equation here. The a value is what you see in front of the x squared. The b value is what you see in front of the x, and the c value is your constant. So when we say b, we're just talking about the number in front of the x. Okay, so what's the number in front of the x? Well, that's just -8. Okay, and then I'll do, what's -8 divided by 2? Well, that's -4. And then what is -4 squared? Well, that's 16. Okay, so I'm gonna do two things here. No, I'm just one step at a time. I'm sorry. Sometimes I get ahead of myself. Okay, so that 16 is essentially what I'm going to add to both sides. Okay, so I'm going to write x squared minus 8x plus 16, and that's equal to -13. And what I do to one side, I must do to the other, right? So plus 16. Okay, so the whole point of this exercise is to get a perfect square binomial on the left side. What's a perfect square binomial? Okay, well, what's a binomial? A binomial is, your two terms. This would be, well, that's in white. This would be a binomial. Okay, a perfect square binomial is a binomial that is a perfect square. I know that's mind-blowing, isn't it? Okay, so we've got x squared minus 8x. Well, how do I know what to factor this into? Well, notice how I did color coordinate the right side. Okay, I color coordinated the right side, so it is abundantly clear what goes where. And then, of course, -13 and a +16 is a +3. Okay, so I said I color coordinated everything to make it abundantly clear, but let's just see why. Let's see how this is abundantly clear. Okay, let's look at this right here. Okay, so obviously the light blue I use in step 2 is what I put into this binomial over here. Again, same thing, color coordinated light blue. Okay, well let's just take this. X minus 4 quantity squared is the same thing as saying x minus 4 times x minus 4, right? Okay. Well, no, let's just FOIL this out. So we're going to have x squared minus 4x minus 4x plus 16. Or in other words, x squared minus 8x plus 16, which is the same thing as this. Okay, so I did say, I kind of skipped over the completing the square that the book gave us, because I like to do this a little bit my way, because I color coordinate everything nice and neat, and that way you see where everything goes. Okay, so I'm going to erase the foiling down there. I showed you that x minus 4 quantity squared is the same thing as saying x squared minus 8x plus 16, and that's the whole point of this. All right, I wanted to get to this point, and now we can solve, right? So what I have to do is I have to take the square root of both sides, right? So it's going to be x minus 4 is equal to plus or minus the square root of 3. It's by taking the square root of both sides. And then x is equal to 4 plus or minus the square root of 3. And that's it, right? So instead of having to, or looking at the original equation and trying to factor it, we'll, it takes you about 4 seconds, if even that long, to see that, oh, I can't factor this. Then I have to complete the square. Okay, and B is in the exact same way. Same procedure, except the first thing we have to do is make sure we divide the entire problem by 3 first. And I guess I'll go ahead and start that up. But let's see here, for the sake of time, I probably won't do it. Yeah, I'll get us started on it, but I will not finish it. Okay, so B, first thing I'm doing is I'm going to divide both sides by 3. So I'm going to have x squared minus 4x plus 2 is equal to 0. x squared minus 4x is equal to -2. I'm going to write down my little algorithm over here. So it's b halves quantity squared. First step, again, I plug in that b. Second step, I actually do the division of 2, and then third step, I square everything. Okay, and I'll stop on that one right there. Good. Obviously, you know where to find these solutions.